earth-shaking giants, an introduction to earthquakes. Earthquakes, even the word itself sounds powerful, doesn't it? These natural phenomena remind us that our planet is a dynamic, ever-changing place. Imagine the ground beneath our feet, seemingly solid and unyielding, suddenly rippling and shaking like a wave. That's an earthquake. But what exactly causes these tremors that can topple cities and reshape landscapes? The answer lies deep within the Earth's structure. Earthquakes occur when massive blocks of rock within the Earth's crust, under immense pressure, suddenly slip past each other. This releases an enormous amount of energy in the form of seismic waves. These waves radiate outwards from the earthquake's origin, the hypocenter, traveling through the Earth and causing the ground to shake. We experience these vibrations as earthquakes. The intensity of the shaking depends on several factors, including the depth of the earthquake, the distance from the epicenter, the point on the surface directly above the hypocenter, and the type of soil or rock the waves travel through. Earthquakes are a stark reminder of the immense forces at play beneath our feet. Understanding these forces is crucial to understanding our planet. By studying earthquakes, we gain insights into Earth's internal structure and the processes that shape its surface. Can we predict the unpredictable? The science of earthquake forecasting. Predicting earthquakes is a complex and challenging task. Scientists can't with certainty say when or where an earthquake will strike. Unlike weather forecasting, which has become more accurate with advancements in technology and our understanding of the atmosphere, predicting earthquakes remains elusive. However, this doesn't mean we're completely in the dark. Seismologists, the scientists who study earthquakes, use various methods to monitor seismic activity and assess risk. They study historical earthquake patterns in specific regions, analyze data from seismometers that detect ground motion, and monitor changes in groundwater levels and gas emissions, which can sometimes signal an impending quake. Despite these efforts, predicting the exact time, location, and magnitude of an earthquake remains a significant challenge. The Earth's crust is incredibly complex, and the processes that lead to earthquakes are not fully understood. While scientists can identify areas at high risk of seismic activity, pinpointing the precise moment an earthquake will occur is not yet possible. Nature's fury unleashed. History's most devastating earthquakes. History is replete with harrowing accounts of devastating earthquakes that have reshaped landscapes and claimed countless lives. These events serve as stark reminders of the immense power of nature and the importance of preparedness. One such catastrophic event was the 2004 Indian Ocean earthquake. This undersea megathrust earthquake, with a magnitude of 9.1 to 9.3, triggered a series of tsunamis that devastated coastal communities across the Indian Ocean, claiming over 230,000 lives. Another devastating earthquake struck Haiti in 2010. The magnitude 7.0 quake, with its epicenter near the capital city of Port-au-Prince, caused widespread destruction, killing an estimated 220,000 people and displacing millions. This tragedy highlighted the vulnerability of densely populated areas with inadequate building practices in earthquake-prone regions. The 1556 Shaanxi earthquake in China is the deadliest earthquake in recorded history, with an estimated death toll of 830,000. This earthquake caused widespread destruction and forever altered the landscape of the region. A shifting grounds the role of tectonic plates and fault lines. To understand earthquakes, we need to delve into the Earth's structure, specifically its tectonic plates. Picture the Earth's outer layer, the lithosphere, as a giant jigsaw puzzle. These puzzle pieces are the tectonic plates, massive slabs of rock that are in constant, albeit very slow, motion. These plates interact with each other in several ways. They can collide, pull apart, or grind past one another. These interactions occur along fault lines, fractures in the Earth's crust, where rocks have moved past each other. Most earthquakes occur along these fault lines. When tectonic plates collide, they can push up mountain ranges or trigger earthquakes. The Himalayas, for instance, are a result of the ongoing collision between the Indian and Eurasian plates. When plates pull apart, magma from the Earth's mantle can rise to the surface, creating new crust. This is how the Mid-Atlantic Ridge, an underwater mountain range, was formed. The San Andreas Fault in California is a prime example of a transform fault, where plates slide horizontally past each other. This fault is responsible for many of California's earthquakes, including the 1906 San Francisco earthquake.